Okay, today we're going to talk about using the graphs of equations. We've already learned that the y-intercept is the y-coordinate of the point where a line crosses the x-axis. So let's go ahead and identify our y-intercept. We should all be really good at this by now. Okay, it is right here, which is -1, -2, -3. Okay, and if I were to list it as an ordered pair, right, it would be 0, -3. And then what we're going to learn about today is the x-intercept. That's the x-coordinate of the point where a line crosses the x-axis. So this crossed at 1, 2, 3, 4, 5, 0. Okay, I listed the ordered pair. You really only have to list 5 and -3. And the reason I wanted to list the ordered pair is to show you that they each have a 0. When you do the x-intercept, the y is 0. When you find the y-intercept, the x is 0. So when it says graph each equation using the x and y-intercepts. So when we go to find the x-intercept, y is going to be 0. So x plus 0 equals 4. So x would equal 4. So my x-intercept, it's crossing the x-axis at 4. Then when I go to find my y-intercept, x is 0. 0 plus y equals 4. So y equals 4. 1, 2, 3, 4. Those are my x and my y-intercepts. And I connect them with my line, and I'm done. Okay, so let's look at number 2. So when I find the x-intercept, y is 0. So it's almost like this part right here just kind of goes away because 5 times 0 is 0. So 4x would be -20. So I would divide by 4 to get x is -1, 2, 3, 4, 5. And then to find my y-intercept, x is 0. So it's almost like that whole part went away, and I'm left with 5y equals -20. I divide both sides by 5 to get y is -4. -1, 2, 3, 4. So when I connect my dots, that is my line. Okay, x and y intercepts are really helpful a lot of in real world situations. Okay, so let's look at this one. It says you plan on using the $80 you received for your birthday on CDs and DVDs. Okay, because that is exactly what y'all are buying. Okay, if DVDs are on sale for $10 and CDs are on sale for $5, write an equation to represent the total number of CDs and DVDs. Okay, so if a CD is $5, it's $5 for every CD. Actually, you know what we're going to do? We're going to say CDs, we're going to change them to X and Y. Our CDs are X and DVDs are Y. Okay, that'll make it a little bit easier. So it's $5 for every CD, $10 for every DVD, and the total is $80. Okay, I wrote that really awful. So $5 for every CD, $10 for every DVD, and the total is $80. So when it asks you to find your x-intercept, that's like saying, well, what if you only bought CDs? You spent all your money on those CDs you've been dying for, right? So you would do 5x equals 80, so you could buy 16 CDs. Okay, but what if you don't even like CDs? You just want to buy all the DVDs. So you would buy 0 CDs, so 5 times 0 is 0. How many DVDs could you buy? 8. If they're $10 each, and you have $80, you could buy 8 DVDs. So now what we're going to do is we are going to graph this. Let me count how many we have here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to have to count by 2s. So I'm going to set up my x-axis here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, and so these are our CDs. And then going up the side are going to be DVDs. 2, 4, 6, 8, 10. So now we get to graph our line. So if I only bought CDs, right, we know that our intercept was 16, so that would be right there. If I only bought DVDs, I could buy 8. So this would be the equation of my line. So let's look at another example. It says, you buy children's books and toys for charity. The books are $4 each and the toys are $2 each. Write an equation that to represent the total number of books and toys you could buy for $24. Then graph. Okay, so books are $4 each. So $4 times every book. Toys are $2 each. $2 times every toy, and you have $24. So the x-intercept, I'm just going to call it the b. Okay, if I only bought books, right, this would go away. I could buy 6 because 24 divided by 4 is 6. Well, what if I only bought toys? 24 divided by 2 is 12. So I'm going to call this the t-axis, this the b-axis, and I think I have enough space where I can count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6. Okay, so if I were to only buy toys, I could buy 12. If I were to only buy books, I could buy 6. I connect those, and that would be the equation or the line to represent that equation. Okay, and what's cool about it is you can actually use a graph like this. It would have been better if I'd used a ruler, but we can use a graph like this to find different combinations. So like, well, what if I bought 2 books? I could buy 1, 2, 3, 4, 5, 6, 7, 8 toys. Okay, and you could keep going and find different points along your line. So why don't y'all go ahead and pause it and do this last word problem, and then you can come back and check your work. Okay, you have $30 to buy lunch for friends. You can buy sandwiches and salads. So I am for sure gonna change this to X and Y. Okay, so I'm gonna say that sandwich is X, salads are Y. So if I am buying sandwiches, okay, they're $2 for every sandwich. And salads are $3 for every salad, and I have a total of $30 to spend. So if I only bought sandwiches, right, 30 divided by 2, I could buy 15 sandwiches. If I only bought $3 salads, I could buy 10 of them. So I have 15 and 10. I am gonna go by 2s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so if I were to only buy, what were these? Sandwiches. Oh, should have gone more. 2, 4, 6, 8, 20. If I were to only buy sandwiches, I could buy 15. So 12, 14, 15. If I were to only buy salads, I could buy 10. And that would be my line.